And now in this lecture we'll find out the length of line segment X. In the drawing we have rectangle ABCD. Inside this rectangle we have those two circles that touch each other externally at this point. This is the touching point, or the point of tendency of those two circles. In addition, we know that this line segment EF is equal to 6 units in its length. Side AD of rectangle ABCD equals to 8 units in its length. And our mission is to find out the length of side AB of rectangle ABCD that is equal to X according to what is given as the equation. So we have to find out the length of AB that is equal to X. Okay, so first of all, we know that ABCD is a rectangle, and we know that all the angles inside the rectangle are right angles. So this angle equals to 90 degrees in rectangle ABCD. This angle also equals to 90 degrees. This angle equals to 90 degrees. And finally, this angle equals also to 90 degrees. In the next step, we will define the center of this small circle as P. We will define the center of this big circle as Q. And I will present to you a new rule, and we will implement the new rule in our drawing. The new rule is rule 11. According to rule 11, the perpendicular to a chord from the center of the circle bisects the chord. So in the drawing we have a circle, and we have point O is the center of the circle. So from the center of this circle, that is to say from point O, we draw perpendicular OM on chord AB. Again, from the center of this circle, that is to say from point O, we draw perpendicular OM on chord AB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. So whenever you have a perpendicular from the center of a circle, then that perpendicular OM also bisects chord AB. That is to say, AM equals to MB. Okay? So whenever you have a perpendicular from the center of the circle, then that perpendicular also bisects the chord that is drawn to. Okay? We can implement rule 11 in our drawing. Here, from the center of this small circle, that is to say from point P, we will draw perpendicular on this chord. So we define the touching point between those two circles, or the point of tendency between those two circles, this point is point S. So in the next step, from point P, that is the center of this small circle, we will draw perpendicular on chord ES. Again, from point P, that is the center of this small circle, we will draw perpendicular on chord ES. So actually, this angle equals to 90 degrees, and this again equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P and code ES as point M, and according to rule 11, the perpendicular PM bisect code ES. That is to say, EM equals to MS. EM equals to MS. So I tell that EM equals to MS according to rule 11. Likewise, from the center of this big circle, that is to say from point Q, we will draw perpendicular on chord SF. Again, from point Q, that is the center of this big circle, we will draw perpendicular on chord SF. So actually, this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point Q and SF as point N, and according to rule 11, the perpendicular QN bisect chord SF. Again, the perpendicular QN bisect chord SF according to rule 11. That is to say, SN equals to NF. SN equals to NF. 1 second SN equals to 1 second NF according to rule 11. We know that EF, this line segment EF, is equals to 6 units. EF equals to 6. But EF equals to ES plus SF. Again, EF equals to ES plus SF. So EF equals to ES plus SF. Okay, so EF equals to 6 and it is equals to ES. ES plus SF. Okay, and ES is EM plus SM. EM plus MS is ES. So EF equals to ES, that is EM plus MS, plus SF. SF is equals to SN plus NF. So in total we found out that EF equals to EM plus MS. But EM equals to MS. So it is EM plus MS plus MS here we substitute EM by MS because EM equals to MS, so EF in total equals to EM, that is MS, plus MS. We substitute EM by MS because EM equals to MS according to rule 11, plus SN plus NF. Here NF equals to Sn. So we substitute Nf in this equation by Nf. Again, we substitute Nf by Sn. So Nf is Sn. So it is Sn plus Sn. So in conclusion, we found out that Ef equals to Ms plus Ms, that is 2Ms, plus Sn plus Sn, that is 2Sn. So in conclusion, we found out that Ef equals to 2Ms plus 2Sn, but Ef equals to 6. So 6 equals to 2Ms plus 2Sn. Here we divide this equation by 2, and finally we get that Ms plus Sn equals to 6 over 2 is 3. So here Ms plus Sn equals to 3. Ms plus Sn equals to 3 units. Okay. In the next step, we define the point of tendency of tangent AB with this small circle SG. We join points P and G together by a straight line. Point P is the center of the small circle, point G is the point on the small circle itself, therefore PG is the radius of this circle. We define the radius of this small circle as A, so PG equals to A. And we have the radius A that is drawn to point G, that is the point of tendency of tangent AB with this small circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius GP. If AB is perpendicular to GP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. We define the point of tendency of tangent AD with this circle as point H. We join points P and H together by a straight line. PH is the radius of this small circle that is equal to A, and we have the radius PH that is drawn to point H, that is the point of tendency of tangent AD with this small circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AD will be perpendicular to the radius HP. If AD is perpendicular to HP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So inside the quadrilateral AGHP, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So inside quadrilateral AGHP, we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to this whole quadrilateral AGHP as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, side HP equals to side AG in rectangle AHPG. But AHP equals to A, therefore AP must be also equal to A. Likewise, according to the same rule, in rectangle AGHP, side GP must be equal to side AH. But GP equals to A, therefore AH must be also equal to A units in its length. In the next step, we'll extend the radius GP by a straight line until it touches side DC. And we define the touching point of the standard radius VP with this side DC as K. So in rectangle in quadrilateral AGDK we have 1, 2, 3 rectangles. Therefore the fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So in quadrilateral AGDK we have 4 right angles. So any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to this quadrilateral AGDK as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So in rectangle AGDK, side AG must be equal to the opposite side DK. But AG equals to A, therefore DK must be also equal to A. According to the same rule, in rectangle AGDK, side AD must be equal to side GK. But AD equals to 8, therefore DK must be also equal to 8 units in its length. So I write it down. That's GK equals to 8. This nice element GK equals to 8 units in its length. We will define the point of tendency of tangent DC with this big circle as L. We join points Q and L together by a straight line. QL is the radius of the big circle. We define the radius of the big circle as B, therefore QL equals to B. We have here the radius QL. The radius QL is drawn from point L, that is the point of tendency of tangent DC with this big circle. And whenever you have a radius that is drawn to the point of tendency, then tangent DC will be perpendicular to the radius LQ. If DC is perpendicular to LQ, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we will define the point of tendency of tangent BC with this big circle as N, and we'll join points Q and N together by a straight line. Qn is the radius of the big circle that is equal to B. The radius Qn is drawn to point N, that is the point of tendency of tangent BC with this big circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius NQ. If BC is perpendicular to NQ, it means that this angle equals to 90 degrees. And this angle also equals to 90 degrees according to rule 1. So inside quadrilateral QNLC, QL and C, we have 1, 2, 3 rectangles. Therefore, the fourth angle must be also equal to 90 degrees according to the rule that the opposite sides of a rectangle are equal. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So in quadrilateral QNLGLC we have 4 rectangles. Therefore we can relate to this quadrilateral as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle QNLC, side QN equals to side LC, but QN equals to B, therefore LC must be also equal to B. Likewise, according to the same rule, side QL equals to side NC. But QN equals to B, therefore NC must be also equal to B. In the next step, we will extend the radius LQ by straight line until it touches side AB. And we'll extend the perpendicular QN by straight line until it touches side AD. And we define the touching point of the extended perpendicular QN with side AD as point T. So here we have quadrilateral TQLD, and this angle equals to 90 degrees. We know that we extended the perpendicular QN by straight line. When you extend the straight line by straight line, the result is a straight line. So QT is one straight line. So on the straight line QT, at point N, the sum of the angles in the lower side of the straight line QT at point N must be equal to 180 degrees. So which angles we have at the lower side of QT at point N? We have this angle that is equal to 90 degrees. Therefore the missing angle must be also equal to 90 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. And we know that EF is a straight line. So if we look on the left side of the straight line EF at point N, the sum of the angles must be equal to 180 degrees. So which angles we have on the left side of the straight line EF at point N? We have this angle that is equal to 90 degrees. Therefore the missing angle must be equal to 90 degrees. According to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So in quadrilateral edge M and T, this quadrilateral we have 1, 2, 3 at angles. Therefore the fourth angle must be also equal to 90 degrees. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay. So we know that AD is one side of rectangle ABCD, therefore it is absolutely a straight line. So if we focus on the right side of the straight line AD at point T, the sum of the angles must be equal to 180 degrees. So which angles we have at the right side of AD at point T? We have this angle that is equal to 90 degrees. Therefore the missing angle must be equal to 90 degrees, according to the rule that the sum of the angles on one side of on a straight line is equal to 180 degrees. We will define the intersection point between line segment GK and line segment TN. This point is point H. So in quadrilateral T edge DK we have 1, 2, 3 right angles. Therefore the fourth angle must be also equal to 90 degrees. So in quadrilateral T edge DK we have 4 right angles. Therefore we can relate to this quadrilateral as a rectangle. We know that the opposite sides of a rectangle are equal to each other. That is to say, side DK must be equal to the opposite side TH. But TK equals to A, therefore TH must be also equal to A. So we know that we extended radius GP is equal to A by straight line. When you extend the straight line by straight line, the result is the straight line. So GK is also one straight line. So in the straight line GK, we have in quadrangle AGDK 1, 2, 3, 4 right angles. Therefore, quadrangle AGDK is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, side AD must be equal to side GK. But AD is equal to 8, therefore GK must be also equal to 8 units in its length. So GK equals to 8. And here we extended the perpendicular QN by straight line, and the result is QT. When you extend the straight line by straight line, the result must be a straight line. So QT is a straight line. So if we focus at the lower side of the straight line QT at point H, here the sum of the angles must be equal to 180 degrees. So which angles we have at the lower side of QT at point H? We have this angle is equal to 90 degrees. Therefore the missing angle here must be also equal to 90 degrees. According to the rule that the sum of the angles on one side of the straight line is equal to 180 degrees. So inside quadrangle HQLK, we have 1, 2 right angles. We know that DC is one side of rectangle ABCD. Therefore, it is absolutely a straight line. So if you focus on the upper side of the straight line DC at point K, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of DC at point K? We have this angle that is 90 degrees, plus the missing angle. In total it must be equal to 180 degrees, according to the rule that I mentioned. Therefore the missing angle must be equal to 90 degrees. So in conclusion, we found out that inside quadrangle HQLK, inside this quadrangle, we have 1, 2, 3 angles. Therefore, the fourth angle must be also equal to 90 degrees, according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. So inside quadrangle HQKL, we have 4 right angles. Therefore, we can relate to this quadrangle HQKL as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. So in rectangle HQKL, side QL must be equal to the opposite side HK. But QL equals to B, therefore HK must be also equal to B. We have already found out that GK is one straight line, because we extended radius GP by straight line, and the result is GK. So GK must be also a straight line that is equal to 8 units. So GK is equal to 8 is equals to GP, that is A, plus PH plus HK, that is B. So GK equals to A plus B plus PH. Okay, GK is equal to 8 is equals to A plus B plus PH. We know that GK is one straight line, so if we focus on the right side of the straight line GK at point H, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the right side of the straight line GK at point H? We have this angle that is equal to 90 degrees. Therefore, the missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles on the right side of the straight line GK at point H 280 degrees, the missing angle must be equal to 90 degrees. So inside quadrangle PMHN we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. So inside quadrangle PM and H we have 4 right angles, therefore we can relate to this quadrangle PHN as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So in rectangle PMHN, side MN must be equal to the opposite side PH. But MN equals to 3, therefore PH must be also equal to 3 units in its length. Okay, so we already found out that 8 equals to GK, that is equal to A plus B plus PH plus B. A plus PH plus B. And we just right now found out that PH equals to 3. So in total, 8 equals to A plus PH, that is 3, plus B. So we actually found out that 8 equals to A plus B plus 3. 8 equals to A plus B plus 3. Here we subtract 3 from this equation and we get that A plus B is equals to 8 minus 3, that is 5. So A plus B equals to 5. In the next step, we join points P and Q together by a straight line. And I present to you a new rule, and we'll implement the new rule in our drawing. According to the new rule, if two circles touch each other externally, that is to say, they have an external length between them, then the straight line that connects their centers together must pass through their touching point. So in the drawing we have those two circles. Those two circles touch each other internally, and this point P. Point P is the point of tendency, therefore we have here an internal match between those two circles. That is to say, they are touching each other. We have an external match between those two circles. That is to say, they are touching each other externally here at point P. And according to this rule number 10, the straight line OM that connects their centers together, here, the center of this big circle is here at point O. The center of this small circle is here at point M. And the straight line that connects their centers together is the straight line OM. And according to this rule 10, the straight line OM must pass through point P, that is their touching point. OPM is one straight line. OPM is one straight line. So whenever you have an external match between two circles, then the straight line that connects their centers together must pass through their touching point. Actually, you can implement all 10 in our drawing. Well, because the small circle touch the big circle here at point S. Point S is their point of tendency, or their touching point. And according to rule 10, where the center of this small circle is here at point P. The center of this big circle is here at point Q. And the straight line that connects their centers together is the straight line PQ. And according to rule 10, the straight line PQ must pass through point S. Again, the straight line PQ must pass through point S, or PSQ is one straight line. So write it down. According to rule 10, PSQ is one straight line. According to rule 10. Why? Because in our drawing here, we have an external match between those two circles at point S. That is to say, they are touching each other externally at point S. Therefore, the straight line that connects their centers together, that is actually PQ, must pass through point S, or PSQ is one straight line. So, what is the length of PQ? Because of the fact that PSQ is one straight line, it means that PQ will be equal to PS plus SQ. Again, PQ will be equal to PS plus SQ. So PQ equals to PS plus SQ because of the fact that PSQ is one straight line. What is the length of PS? P is the center of this small circle, and S is the point of the small circle itself. This is exactly the definition of a radius. Therefore, PS is the radius of this small circle that is equal to A, according to our definition. What is the length of SQ? SQ starts from point Q, that is the center of the big circle, and S is point S, that is the point of the big circle itself. This is exactly the definition of a radius. So QS is the radius of this big circle that is equal to B. So in total, PQ equals to A plus B. Okay. PQ equals to PS, that is A, plus SQ, that is B. So PQ equals to A plus B. But we have already found out that A plus B equals to 5. Yeah, A plus B equals to 5. A plus B equals to 5. And from those two equations, PQ equals to A plus B and A plus B equals to 5. A plus B equals to 5. We derive that PQ also equals to 5. PQ equals to 5. The hypotenuse PQ of the right triangle PHQ equals to 5. In the next step, we will implement the Pythagoras theorem on the right green triangle PHQ. So I copy the right green triangle PHQ in a new page, and we will implement on it the Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. We have already found out that pH equals to 3 units. Here by PT is abbreviation for Pythagoras theorem. So according to Pythagoras theorem, in this right triangle PHQ, PQ squared, that is the square of the hypotenuse, must be equal to PH squared plus HQ squared. So PQ is 5, therefore PQ squared is 5 squared, that is 25. And it equals to PH squared. PH is 3, therefore PH squared is 3 squared, that is 9, plus HQ squared. Here we subtract 9 from this equation, and we get that HQ squared equals to 25 minus 9 is 16. Here we take a root out of this equation, and finally we get that HQ equals to the square root of 16, that is 9. HQ is square root of 16, that is 4. So HQ equals to 4. HQ equals to 4 units in its length. Quadrilateral A, B, T, N, this quadrilateral. Inside this quadrilateral we have 1, 2, 3, 4 right angles. Therefore quadrilateral A, B, T, N is a rectangle. Quadrilateral A, B, T, N is a rectangle. And you know that the opposite sides of a rectangle are equal to each other. That is to say, side AB is equal to x equal to side Tn in rectangle ABTN. AB equals to the opposite side Tn in rectangle ABTN. But AB equals to x. For this equation, x equals to AB equals to Tn, we will derive that x equals to Tn. X equals to Tn. So we find out the length of Tn, and that will be the answer to this question, because x equals to Tn. Our mission is to find out the length of line segment x, that is AB. So what is the length of Tn? What is the length of side Tn? From the drawing, it is very easy to see that Tn equals to T edge, that is A, plus HQ, that is 4, plus QN, that is B. So in conclusion, found out that Tn equals to A plus B plus 4. So Tn equals to, we already found out that A plus B equals to 5, so we substitute A plus B by 5. So Tn equals to A plus B, that is 5, plus 4. So we found out that Tn equals to 5 plus 4, that is 9. So Tn equals to 9. And Tn equals to x. Tn equals to x. On this equation we derive that x equals to 9 units. X equals to 9 units in its length. That is the answer to the question. Read again. The length of line segment AB is equal to x, it is equals to 9 units. So in the next step, I'll summarize the lecture. In this lecture, we found out the length of this 970 bit is equal to x. Okay, so in the drawing we have two circles that are tangent to each other at this point. This is their touching point, and we also know that ABCD is a rectangle. Inside this rectangle we have those two circles that touch each other here at this point. This is their point of tendency. In addition, we know that line segment EF equals to 6 units in its length, and line segment AD equals to 8 units in its length. Again, our mission is to find out the length of line segment AB is equal to x. Okay. So first of all, because of the fact that ABCD is a rectangle, we know that all the angles inside the rectangle are right angles. So those four angles are all right angles. We define the center of this circle as P, we define the center of this circle as Q, and we define the touching point between those two circles as point S, or the point of tendency as point S. Then I presented to you the new rule, and we implemented the new rule in our drawing. The new rule is Rule 11. According to Rule 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. So in the drawing we have a circle, the center of this circle is here at point O. Inside this circle we have chord AB. From the center of this circle, that is to say from point O, we draw perpendicular on chord AB. We define the touching point of the perpendicular from point O, that is the center of the circle, and AB is M. So according to this rule, Rule 11, we have first of all the perpendicular OM. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. And according to this rule, Rule 11, the perpendicular OM also bisects chord AB. If OM bisects chord AB, it means that AM equals to MB. Here AM equals to MB because the perpendicular OM bisects chord AB. It means that it divides it into two halves. So AM is the first half and the MB is the second half. And AM equals to MB. We can actually implement Rule 11 in our drawing. Why? Because in our drawing from point P, that is the center of this small circle, we draw perpendicular on chord ES. So this angle equals 90 degrees and this angle equals 90 degrees according to our construction. We define the touching point of the perpendicular from point P and chord ES as M. So the perpendicular PM, according to Rule 11, bisects chord ES. That is to say, EM equals to MS. EM equals to MS according to Rule 11. According to Rule 11, EM equals to MS. Likewise, from the center of this big circle, that is to say from point Q, we draw perpendicular on chord SF. Again, from point Q, that is the center of this big circle, we draw perpendicular on chord SF. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. And according to rule 11, the perpendicular QN also bisect chord SF. That is to say, Sn equals to NF according to the same rule, rule 11. Here, Sn equals to NF according to rule 11. So, we know it is given us the question that EF equals to 6 units. This line segment EF equals to 6 units. So EF equals to 6, and EF also equals, from the door it is very easy to see that EF also equals to ES plus SF. Again, EF equals to ES plus SF. So EF equals to ES plus SF. So EF equals to ES plus SF. ES plus SF, and in total EF equals to ES plus SF. Okay, but ES equals to EM plus MS. Again, ES equals to EM plus MS. So we substitute ES by EM plus MS plus SF. SF equals to SN plus NF. Again, SF equals to SN plus NF. So we substitute SF by SN plus NF. Okay, we substitute SF by Sn plus Nf. So we can find out that EF equals to EM plus MS plus Sn plus Nf. Okay. So EF equals to EM plus MS. EM plus MS. But we know that EM equals to MS, so we can substitute EM by MS. We substitute EM by MS, so ES will be equal to MS plus MS. MS plus MS. Because EM equals to MS. So EF equals to MS plus MS plus SN plus NF. We know that Sn equals to NF, so we can substitute NF by Sn. Okay? So it will be equal to 2 times MS plus 2 times NS, 2 times NS, 2 times Sn, because Sn equals to NF. So we can find out that EF is equal to 6 equals to 2 times MS plus 2 times Sn. We divided this equation by 2 and finally found out that MS plus Sn equals to 3. Here MS plus Sn equals to 3 units. Or Mn equals to 3 units in its length. Mn equals to 3 units in its length. Then we implemented rule 1 in our drawing. We have here, we defined the radius of this circle as A and the radius of the big circle as B. We have the radius QL that is going to point L, that is the point of tendency of tangent DC with this big circle, and whenever you have a radius that is going to the point of tendency, then tangent DC will be perpendicular to the radius LQ, that is to say this angle equals to 90 degrees and this angle equals to 90 degrees according to rule 1. Likewise, we join points Q and N together by straight line. Qn is the radius of the big circle that is equal to B. The radius Qn is drawn to point N, therefore according to rule 1 this angle equals to 90 degrees and this angle also equals to 90 degrees. Likewise, we join points P and Q together by a straight line. PG is the radius of this small circle is equal to A. The radius PG is drawn to point G, therefore according to rule 1 this angle equals to 90 degrees and this angle also equals to 90 degrees. Likewise, we join points P and N together by a straight line. PH is the radius of this small circle that is equal to A. The radius PH is drawn to point H, that is the point of tendency of tangent AD with this small circle, and whenever you have radius that is drawn to the point of tendency, then tangent AD will be perpendicular to the radius HP. If AD is perpendicular to HP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule 1. So inside the small quadrilateral AGHP we have 1, 2, 3 angles, therefore the fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So inside quadrilateral AGHP we have 4 angles, therefore we can relate to this quadrilateral it's a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say in rectangle AGHP, side P equals to side AG. But HP is 8, therefore AG must be also equal to 8. Likewise, according to the same rule, in rectangle AGPH, side GP must be equal to the opposite side AH. But GP is 8, therefore AH must be also equal to 8. So actually found out that quadrilateral AGHP is not a rectangle, but a square. Why? Because all of its sides are equal to each other. Each side of this quadrilateral is equal to 8, therefore quadrilateral AGHP is a square. Okay. Then we extended the radius GP of this small circle by a straight line until it touches side DC at point K. So inside the big quadrilateral AGDK, inside this quadrilateral we have 1, 2, 3 rectangles. Therefore the fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So inside this quadrilateral AGDK we have 4 angles, therefore we can relate to this quadrilateral as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, side AG must be equal to the opposite side DK in rectangle AGDK, but AG is 8, therefore DK must be also equal to 8. Likewise, according to the sub-rule, side AD must be equal to the opposite side GK in rectangle AGDK, but AD is 8, therefore GK must be also equal to 8 units in its length. Here GK equals to 8 units in its length. Then we extended the perpendicular QN by a straight line until it touches side AD. We define the touching point as T. So QN is a perpendicular, it is a straight line. When we extend a straight line by straight line, the result is a straight line. So QT is a straight line. So if we focus on quadrilateral TNDC, inside this quadrilateral TNDC we have 1, 2, 3 rectangles, therefore the fourth angle here must be equal to 90 degrees. Now inside quadrilateral THKD we have 1, 2, 3 rectangles, therefore the fourth angle must be also equal to 90 degrees. And we know that QT is a straight line, so this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. We have already found out that this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees. Why? Because we know that DC is one side of rectangle ABCD, therefore it is absolutely a straight line. So if we focus on the upper side of the straight line DC at point K, the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of this set point K, we have this angle that is equal to 90 degrees plus the missing angle, in total it must be equal to 180 degrees. Therefore the missing angle here must be equal to 90 degrees. Okay. So inside a quadrangle HQLK we have 1, 2, 3 angles, therefore the fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore quadrangle HQLK has 4 angles, and we also therefore can relate to this quadrangle HQLK as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, side QL must be equal to the opposite side HK in rectangle HQKL. But QL equals to B, therefore HK must be also equal to B. Okay. So we already found out that the length of the straight line GK is 8. GK equals to 8. So GK is equal to 8 is equal to A plus 3 plus B. Again, GK is equal to 8, it is equal to A plus B plus 3. A plus B plus 3, we subtracted, so 8 equals to A plus B plus 3. We subtracted 3 from this equation and finally found out that A plus B equals to 5. A plus B equals to 5. Then we joined points P and Q together by straight line. And then I presented to you rule 10, and we implemented rule 10 in our drawing. According to rule 10, whenever you have an external launch between two circles, that is to say the two circles are touching each other externally, then the straight line that connects their centers together, in this case is the straight line MO, must pass through their touching point. This case is point P. The straight line MO must pass through point P, or MPO is one straight line. Okay, MPO is one straight line. So whenever you have an external launch between two circles, the straight line that connects their centers together must pass through their touching point. In this case, the straight line MO must pass through point P, or MPO is one straight line. You can implement all 10 in our drawing. One, because in our drawing, those two circles have an external launch between them, that is to say they are touching each other externally here at point S. The center of the small circle is here at point P. The center of this big circle is here at point Q. And the straight line that connects the centers together is the straight line PQ. And according to rule 10, the straight line PQ must pass through point S, or PSQ is one straight line. PSQ is one straight line. It again, according to rule 10, PSQ is one straight line. So if PSQ is one straight line, it means that PQ will be equal to PS plus SQ. Okay, PQ equals to PS plus SQ. So PQ equals to PS. What is the definition of line segment PS? Line segment PS starts from point P, that is the center of the small circle, and ends at point S, that is the point of the small circle itself. This is exactly the definition of a radius. So PS is the radius of this small circle that is equal to A, according to our definition, plus SQ. So we can substitute PS here by A plus SQ. What is the definition of line segment SQ? Line segment SQ starts from point Q, that is the center of the big circle, and ends at point S, that is the point of the big circle itself. This is exactly the definition of a radius. So QS is the radius of the big circle, that's equal to B units according to our definition. So we can substitute QS by B. So in conclusion, found out that PQ equals to A plus B, and we have already found out that A plus B equals to 5. So we can write here that A plus B equals to 5, and from this equation PQ equals to A plus B equals to 5, we will derive that PQ also equals to 5. PQ, the distance between the centers of those two circles, PQ, is equals to 5 units. Okay? So here we already found out that inside the quadrilateral PMHN we have 4 rectangles, therefore quadrilateral PHMN is a rectangle, and we know that the opposite sides of a rectangle are equal to each other, that is to say side MN equals to side PH, but MN is free, therefore PH is also free. So in the green right rectangle PHQN, the hypotenuse PQ equals to 5 and side PH equals to 3. So we implemented the Pythagoras theorem on this right hand triangle PHQ. So actually I copied the right triangle PHQ in a new page and implemented on it the Pythagoras theorem. This is the right triangle PHQ. According to the Pythagoras theorem, PQ square equals to PH square plus HQ square. PQ is 5, therefore PQ square is 5 squared, that is 25, and it is equals to PH square. PH is 3, therefore PH square is 3 squared, that is 9, plus HQ square. So I conclude found out that the 25 equals to 9 plus HQ square. Here we subtracted 9 from this equation, and finally found out that HQ square equals to 25 minus 9, that is 16. So HQ square equals to 16. Here we took a root out of this equation and finally found out that HQ equals to the square root of 16, that is 4. So here we found out that this line segment HQ equals to 4 units in its length. And we already found out that quadrilateral TDKH is a rectangle, and we also know that the opposite sides of a rectangle are equal to each other. That is to say, side DK must be equal to the opposite side TH in rectangle TDKH. But DK equals to A, therefore TH must be also equal to A. And we have already found out that here inside quadrilateral QLCN we have 1, 2, 3 rectangles, therefore the fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So this angle equals to 90 degrees, therefore inside quadrilateral QNLC we have 4 right angles, and any quadrilateral that those 4 right angles must be at least a rectangle, it's not a square, so we relate to this quadrilateral as a rectangle, and we also know that the opposite sides of a rectangle are equal to each other. So actually, anyway, we know that QN is the radius of the big circle that is equal to B. Okay, so inside the quadrilateral ABTN we have 1, 2, 3, 4 right angles. Therefore we can relate to this quadrilateral ABTN as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, side AB must be equal to side TN in rectangle ABTN. But AB equals to X, therefore TN must be also equal to X. Repeat again. Quadrilateral ABTN is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, AB equals to side AB equals to the opposite side TN in rectangle ABTN, but AB equals to X, therefore, for this equation X equals to AB equals to TN, we derive that TN equals to X units. TN equals to X. So Tn equals to X. So what is the length of Tn? From the drawing, it is very easy to see that Tn in total equals to A plus 4 plus B. Again, Tn in total equals to A plus 4 plus B. Tn equals to A plus 4 plus B. That is to say Tn equals to A plus B plus 4. And we already found out that A plus B equals to 5. So we can substitute A plus B in this equation by 5. So Tn equals to A plus B, that is 5 plus 4. So Tn equals to 5 plus 4, that is 9. So Tn equals to 9. This 970N equals to 9. And we have already found out that x equals to Tn. And for this equation, x equals to Tn equals to 9, we will derive that x equals to 9 units. So in conclusion, we found out that the length of line segment AB is equal to x, it is equal to 9 units. Okay, thank you very much.